Okay, so I'm going to try something new, which is a Steve Jobs introduction. What if I told you you could have R on your phone, no internet, no server, just R in your pocket? That was good? Yeah? Okay. Thank you. But before that, a bit of history about R. So back in the day, there was a terminal. A terminal is something you can type in. And back in the day, I'm talking 25, 30 years ago, probably some of you were not even born in 2000, but when R1 was released, it was only a command line tool. So the only way you could interact with R was through this command line, through a terminal. So basically, back in the day, R, it was something which could be called nerd-oriented, in the sense that with a terminal, you needed to be a bit nerdy, a bit grumpy, with a gray bird and everything, and just you had to compile it, you have to download it, you had to know how to deal with makefiles and things like that. So it was a bit complicated to use R back in this day. And then there were user interface and IDE. So for people who were less grumpy, but you had your IDE, so RStudio, VS Code, Positron, things like that. So some stuff which were which made R easier to use, but which was still for nerdy people. So just a small poll. So when did you start using R? Did you start with a terminal, meaning that you used underscore for assignment? I know Colin did. So we started R like 25 years ago. And we started with like the GUI and things like that. And we started like recently, so we follow Positron, who follow Posit on TikTok? I don't even know if they have a TikTok, but I know they have an Instagram account, but So basically, back in the day, you needed to compile R from source. You needed to install it in your terminal. It was a bit complicated. Even with the IDE, you still need to install the IDE, install R, install the packages. Like you need to figure out how it works. But in 2012, something new was born. Something arrived in the R world that changed the way R was used. And it's called Shiny. So Shiny changed the game in the sense that R was now available for people with no technical knowledge, like the end users that could simply use a browser to access a web app. And it brought statisticians and users together in the sense that people could have access to R code without even writing any line of code. So Shiny arrived, and it was great on desktop. So if you use your computer to access a Shiny app, it works well, but it was not thought as a tool that needed to be used on mobile. So because at that time there were not that many mobiles, but basically it is a great tool for computer, for people who need to access apps and websites with web browser. But since then, the world has changed a little bit. TikTok arrived, and people add more and more mobiles. So there are mobiles everywhere, as Colin said. Everybody has a phone in their pocket, so everybody now has a mobile. And I'm not sure I need a graph to prove it. Do I need a graph? Yeah. I made a very good graph, I bet. So this is the number of phones over time. So basically, mobiles are everywhere. Everybody's got a phone in their pocket. They need to. I mean, some people spend more time on their phone than on their computer. So what that means is that with these mobiles everywhere, there were new needs. Because basically, when you want an information, we are becoming less and less patient. We really want the information right now. We really just want to consume content or to have information just in a couple of seconds, just taking our phone out of our pocket and getting access to data, to the information, to things like that. And of course, if you have your phone, you don't have a reliable internet connection every time. So for example, I traveled from Paris to there via train, and basically you don't have internet all the time. So if you need to work on a Shiny app, for example, Shiny app needs an internet connection. So if you want to use a Shiny app while you are traveling, basically you can't do it all the time because you don't have access to internet. And of course, if you are using your phone, you need a good user experience, so something that looks like a native web app. So we're all using apps on our phone on a daily basis, and we want a good user experience, so we want to have something that looks like any other app. So there have been a lot of tests or things that happened with in the Shiny world that tried to bring Shiny to mobile, but I think that they showed their limits. So for example, there had been a work on responsiveness. So responsiveness is a way for your app to be displayed in different viewports, whether you have, a small screen, large screen, if you're in landscape portraits or things like that. Progressive web app, there is a good, cool package called shinyMobile that really help you build Shiny apps with a mobile design, so it works well. If you open the app with your phone, it displays correctly, and it's really great. But the issue is that you still need internet, because basically Shiny is running R. So R is running on a server somewhere, and your phone is connecting to this server via the browser. So most of the time, you will still need an internet connection, which is kind of hard when you are on your phone and you are on the move. You're not sure that you always have access to the internet. Of course, it can't be deployed on app stores. When I'm talking about app stores, the app stores of the Google Play Store of, I don't know, depending on the type of phone you have. But basically, Shiny apps, by default, can't be deployed on app stores because the app stores expect a specific type of application, so written in a specific language, which is compiled in a binary, then sent to the app store to be validated. So they don't accept like a Shiny app or R code, basically. And something also which is a little bit less important, but which is nice anyway, is that with Shiny apps, you don't have access to the phone APIs. What I mean by that is, for example, when your phone is vibrating, or you have a bunch of things like movement, health, things like that, that are native to your phone, a number of steps you're doing every day, things like that. You don't have access to it from a Shiny app, which is normal because basically your web browser doesn't have access to it for security reasons. So you don't have access to these through Shiny because it's a web app and you need to use it via a browser. But over the years, clients have been coming and say, we need a native mobile solution. we need to put Shiny on mobiles. So I work at a company called ThinkR, and we do Shiny and R, and I think it's been 8 years and a half since I started working there, and I think twice a year we've been asking, hey, I have a Shiny app, can I put it on a mobile? Hey, I have a Shiny app, can I put it on a mobile? And basically the answer is more or less always the same. No, it's not possible. It's not possible. You can't do it with Shiny right now. So last summer, we got one of these calls, again, a client that needed a native app. When I say native app, so it's an app that you can use, that you can install on your phone. You have the logo on your home, you open it, it's an app. So they wanted a native app, an app that worked offline, and something that they could distribute through the App Store. Sorry. So we were about to say that it was impossible, like every other time, just saying, no, it's not possible with Shiny, it's not possible right now with Shiny. And then we stopped and we said, what if? So this is my second Steve Jobs moment, look. So what if webR could do it? So what if we could use something like webR to build a native app? So everybody know what webR is? More or less? Okay, good. So webR is a version of a statistical language compiled for the browser and Node.js using WebAssembly via, I think it's Emscripten. I'm not sure how it's pronounced. So once you know that, you just say, what? Okay, so let me explain to you a little bit more in details what that means. So if you think about a recipe, so you have a recipe written somewhere to make cookies, and on the other side you have somewhere you have something that you can use to cook to prepare this cookie. So basically you have the definition and you have somewhere to do the recipe. So this is the very same thing with code. Basically you have somewhere are sources, which are text files defining R, defining what R is. And you have to take these source files and turn them into a way that your computer can understand. So basically, text file turned into a program. So this is what compiling means. You take the text file and you turn them into a program. So historically, R was, was compiled for Windows, Linux, and Apple, so Mac OS. So historically, we compiled R for these operating system. I think we used to compile for obscure operating system like Solaris. I'm sure if you have a question, you can ask Colin. I'm sure we've done it. But now webR is a way to run R into any environment, any runtime that can call JavaScript. So basically now R is usable on Windows, Linux, Mac OS, and JavaScript. So knowing that, we had this crazy idea of using webR to build a phone app, because basically now you have frameworks for a phone to build a mobile app that use JavaScript. And then you build your app in JavaScript, and it's then compiled to something that you can send to iPhone or to Android, or all the. So it can be compiled to a format that can be sent to the App Store. So we had this idea, let's try to bring R inside a mobile app. So this is something that hasn't been done before, so our client wasn't ready to pay for the exploration, but we decided to to explore it anyway. We tried. We decided that okay, let's try and put this crazy idea into practice and see if it works. And that's so we cooked something which is called Rlinguo. So Rlinguo is a native web app with the backend which is written in R. So it's kind of a way to learn R. So it's a small game where you've got a list of functions and you have to guess from which package it is coming from. So it can be used offline. It has the native performance, so you don't have the load time you could have with an internet-based app. So it's really fast to run, and if you open it one time, you do something else and you come back, it's still open. So it's been built with a mobile framework. So basically, it's very mobile friendly because we used templates for building web apps. So we decided that we would use a framework, and it works well. It uses the mobile API in a sense that, for example, you have a small SQLite database available on your machine, on your phone, so it accesses this small database, it vibrates, things like that. So just the vibration doesn't bring anything, but we just wanted to prove that it's possible. And of course, it's distributed on stores, so if you want to install it from Google Play or Apple Store, it will work. So we managed to bring it to the phone with all these elements, with these requirements. So the question you could have is, where is R if you look at this application? And I think that if you ask yourself where is R and you don't see that it's an R-based product, yeah, so it's a success for this app. But so we have R here. So we have a small function called getContents, which is going to sample all the installed package on the phone. This is something that we wanted to be sure we could do also, is to install other packages. So we have another packages which is installed and comes with the app. So it samples the installed packages of the phone. We also sample and takes one of the function from one of these package, just to be sure that you can play the game. So it's a small sample here. So we have also, so as I said, we access the SQL database on your phone, and it stores how many attempts it takes you to guess the function, so 1, 2, or 3. So we store this value in the database, and when we take the information from this table, we do like a base table, because basically doing something like this in JavaScript, just counting, is kind of a pain to do it. So basically it's kind of hard. So we use R to do a table of package attempt. And of course we have on the about, we have a small R code that just do a round of runif. Basically just if you click on the button, it runs the R code just to prove how it works. So it's, of course it's a proof of concept, but basically the idea is to have some places in the app where you have our code running. So how it works, you open the app. First thing that happens is that it loads a JavaScript runtime. So basically either on your iPhone or on your Android, it loads a JavaScript runtime. So as I said before, a runtime is somewhere where you can run code. So it loads a JavaScript runtime. We then load webR inside this runtime. When it's loaded, we are loading the R functions. so it's called an R object, so proxies in the webR language. And once we have these R objects in JavaScript, we call R through these proxies. So basically, we have all the interaction which happens in JavaScript, and once you click a button, it calls R to verify your input, to give you a new suggestions or things like that. So this is like a bit of code, but when we start, we load R. We have a bunch of internal function just to send the script and just to be sure that webR is able to get the scripts with a function. And then we create in JavaScript these R objects, which are called proxies, which are basically no JavaScript function that under the hood are able to call webR. And then when the user is interacting with the app, we call the function again. So for example, get content from before. And same here with score table, computing the table of answer. So this is me for showing like JavaScript code at an R conference. I gave a workshop yesterday where I was showing a lot of JavaScript. No, I still. So yeah. So the big question is, why would you want to do this? So for whom? Why would you want to do it? So for example, if you are a scientist in a remote area and you have no internet connection and you want to enter data or analyze things, you might want to have it on your phone. If you are a student and you want to learn R, but you don't have, you don't want to take your laptop out in the metro or things like that. You want to learn R on your phone. This is something that can be done. We could build a tool to learn R. If you are on a production line in a factory and you are just walking around, you don't want to walk with your computer in your hand. Basically, you can use it. Something on a tablet or on the phone, just to analyze, to do some analysis. Same if you are a medic or healthcare and you work in remote area with no stable internet and you have to input data or things like that. It can be a way to use it. So a big question is I'm at a Shiny conference showing JavaScript code with webR in it, so no Shiny. But to my defense, Colin invited me, so so is it the end of Shiny? No, it's not. You can't do everything on your phone. Basically, if you have large model, large computation, things that are, and there are things that you only do on your laptop. Basically, it's not the end of Shiny. So you can't do everything on your phone, but there are things that could happen only on your phone, so for smaller data sets, for smaller computation or things like that. So for now, it's just a proof of concept. I would like to open source the template so that anybody can build their own. So I've been saying this for 6 months, so at some point I need to do it. If I keep telling people that I'm going to open source it, I need to do it. So feel free to download it and just try it and see how it works. And this is the last Steve Jobs moment. Once upon a time, R lived in the terminal, and now it lives in your pocket. Thank you. Feel free to talk to me, or if you can reach me there if you wish.